This LOS is calculate and interpret a confidence interval for a population mean given a normal distribution with 1, a known population variance, 2, an unknown population variance, or 3, an unknown variance and a large sample size. This example looks very similar to what we've seen in a previous LOS, but the difference here is we're talking about the sample. This sample has a standard deviation of 0.3. We don't know the population standard deviation. So in that case, we're going to use the t-tables, okay? And the t-table is presented as a one-tailed table. And here we're looking for 90% confidence interval. So when it's 90%, this is the column that you need to use because it's a two-tailed. We're looking at the confidence on a mean. So we're looking at both the left-hand side and the right-hand side. So when they give you 90% confidence interval, but you're using a one-tailed table, we're going to use the p equals 0.05, okay? So that gives us a little bit different number than the z-table. Recall, it's going to be a little bit higher. It's 1.65 versus 1 on the z-table versus 1.66. So it's going to give us a little bit of a wider range when we use the t-table, and that's why they say that it's more conservative, okay? So in this example, we're looking at a sample size of 100, so n equals 100. The Sharpe ratio, the average, the x bar equals 0.45, and the sample has a standard deviation, s, of 0.3. And we want to calculate, interpret the 90% confidence interval for the mean, okay? So step 1, you need to calculate the standard error, which is the standard deviation divided by the square root of n. So we've got that 0.03. Then we're going to calculate the confidence interval, which we know is the, we've got up here the point estimate, 0.45, plus or minus 1.66. We've got that from the table, our reliability factor, times the 0.03. So it's 0.45 plus or minus 0.0498, and the interval is going to span 0.40002 to 0.49980. I wrote here this is not a big difference. This is relative to the previous LOS that we saw when we knew the standard deviation of the population. So we were using the z-table, and for the same confidence, the z-table is going to give us a reliability factor of 1.65. So it's a very, very small difference in this case. So for the rest of this LOS, we're just going to do 4 practice questions to consolidate your understanding. So the first one, an increase in which of the following items is most likely to result in a wider confidence interval for the population mean? A, sample size, B, reliability factor, or C, degrees of freedom? Okay, that was a nice little practice question. The correct answer is B. By increasing the reliability factor, you're going to have a wider confidence interval. Because remember the formula, it's the point estimate plus or minus the reliability factor times the standard error. So if you increase the reliability factor, you're going to have a wider confidence interval, a wider range, okay? So on the sample size, no, if you increase the sample size, remember here's the formula for standard error. If you increase the sample size, that's the denominator, you're going to increase the denominator, you're going to decrease the standard error, you're going to decrease the interval. And the other one is the degrees of freedom for C. I just cut out a little piece. You can see as you increase the degrees of freedom, what's happening? Your reliability factor is going down. So just remember that. As you increase the degrees of freedom, your reliability factor is going down. So if that's going down, then you're also making the range more narrow. Nice little practice question. So another practice question, this one's just the opposite of the previous one. All else held constant, the width of the confidence interval is most likely to be smaller if the sample size is A, larger and the degree of confidence is lower, B, larger and the degree of confidence is higher, or C, smaller and the degree of confidence is lower. Okay, that was a nice little practice question. So as we saw from the previous question, as we increase the sample size and increasing the degrees of freedom, that both shrinks the confidence interval. So a smaller sample size, we want to most likely looking for the smaller one. So a smaller sample size, no, because we want to look for increasing the sample size. So C is wrong. So now it's going to be between A and B, okay? And they both have a larger sample size. Now we're looking at the degree of confidence is lower or the degree of confidence is higher. So just remember, let's say this is 90% degree of confidence versus 95% degree of confidence. So if we look here, remember, if this is one-tailed table, so if we're looking at two-tailed, here's our 90% and here's our 95%. We can see that the reliability factor is going up. So as you increase the degree of confidence, you're increasing the reliability factor, you're increasing the confidence interval. So to be smaller, most likely smaller, you want the lower degree of confidence. So the correct answer is A. As we increase the degree of confidence, the confidence interval becomes wider. So again, my advice for doing these type of questions on an exam environment is not to just think it all through your head. Write these things out and then compare it versus what you want to answer. So a good little question, that one. Another practice question on calculating confidence intervals. So it says use the following values from the student's t-distribution to establish a 95% confidence interval for the population mean given a sample size of 10, a sample mean of 6.25, and a sample standard deviation of 12. Assume that the population from which the sample is drawn is normally distributed and the population variance is not known. So they've given you the table. The 95% confidence interval is closest to A, a lower bound of negative 2.33 and an upper bound of 14.83, a lower bound of negative 2.2, upper bound of 14.7, or C, a lower bound of 0.71 and an upper bound of 13.2. Okay, it's a small sample size, but it is a normal distribution. We can use the t. Okay, the degrees of freedom is n minus 1. So we know that the sample size is 10. We're going to be using the row for 9. And it's two-tailed because we're looking at a sample mean and we want to have a range. So it's both sides, left and right. So we're going to use 5% divided by 2. 95% confidence, 5% divided by 2. We're going to use the 0.025 column. So it's important that you use the right column. If you don't, then you're going to get the wrong answer, okay? So that's the first thing. Note, as I said, if it's non-normal and a small size, the reliability is not possible. So just be on the lookout for a question like that on any type of exam where they're giving you two choices and one is saying it's not reliable, not possible. That would be the case if it's non-normal and a small size, okay? So then we're going to go through the steps again. Here's how we calculate it. We have our point estimate, which is 6.25. That's our point estimate, plus or minus the reliability factor, 2.262, and then it's going to be times by our multiplied by our standard error, and we have the standard deviation of 12. Just be careful they give us the variance because we'd have to take the square root divided by the square root of n, which is 10, okay? So that's one little thing here. They gave you the sample standard deviation. Just be careful if they give you the variance. You're going to have to do a little bit of an adjustment. So if you work your way through the math, you're going to see that you get the correct answer is A. So the correct answer is A on that. One last practice problem for this LOS. An analyst wants to estimate the return on the S&P 500 for the current year using the following data and assumptions. Sample size equals 50 stocks from the index. Mean return for those stocks in the sample for the previous year is 0.114, so that's 11.4%. Variance equals 0.0529. The reliability factor for a 95% confidence interval with an unknown population variance and sample size greater than 30 is 1.96. So you need to calculate the confidence interval. A, 0.09934 to 0.12866. B, 0.05025 to 0.17775. Or C, negative 0.3368 to 0.5648. Okay, this question's not too bad because they gave us the reliability factor and we're going to use it. But you see here they gave us the variance 0.0529. So when we have to calculate the standard error of the estimate, remember the numerator is using the standard deviation, so we need to take the square root of the variance. And that's just the one little trick to be careful. And so then again, the point estimate is giving us the mean return, 0.114, plus or minus our reliability factor, which they were nice to give us in this question, times by the standard error of the estimate. So you can see that's the square root of the variance. So we had 0.23 in the numerator divided by the square root of n. And in this sample size, they gave us 50. So that's the square root of 50. And if you work your way through the math, you're going to get the correct answer is B. The confidence interval is going to be from plus 0.05025 to plus 0.1775. And that's the last slide for this LOS. Thank you.